Hey, what's up, my chemistry people? Who's ready for a fantastic free response? All right, we are told that methane gas reacts with chlorine gas to form dichloromethane and hydrogen chloride, as represented by the equation above. Boom! Part A. A 25.0 gram sample of methane gas is placed in a reaction vessel containing 2.58 moles of chlorine gas. Identify the limiting reactant when the methane and chlorine gases are combined. Justify your answer with a calculation. Right, again, there are a couple different ways to identify limiting reactants. I'm going to show you one way, but if you have a different way that works, as long as you justify it, show your work, good to go. All right, I'm going to start with 25.0 grams of methane. First thing I'm going to do is convert that to moles. The molar mass of methane is 16.024. Then finally, I'm going to convert that to moles of one of my products. Now, I chose dichloromethane, but you could have also chose the hydrogen chloride. The relationship between methane and dichloromethane is 1:1. Calculator time. 25.0 divided by 16.024 gives me moles of methane. Also gives me moles of dichloromethane because the ratio is 1:1. So the correct number of sig figs, 1.56 moles of dichloromethane. All right, now we're just getting started. We want to think about, well, what happens if chlorine, my other reactant, was the limiting reactant? So I'm going to take 2.58 moles. Since it's already in moles, I can bypass that step and just compare it to moles of dichloromethane. That relationship is 2:1. Quick jump to my calculator, 2.58 divided by 2, which means that I would make 1.29 moles of dichloromethane. Okay, so let's think about what these calculations tell me. Basically, what I've done is I've calculated theoretically how much of the dichloromethane I could make if I completely reacted each of those reactants. Remember that a limiting reactant is going to limit how much product you can make. It's the one that determines how much product you can make. So as I look at my work, the smallest amount of product made came from the 2.58 moles of chlorine. So chlorine is the limiting reactant. Don't forget to answer the question because it produces the smallest amount of product. Boom! A lot of work for 1 point. Let's keep going. Next, we got A part II. Calculate the total number of moles of gas in the container after the limiting reactant has been totally consumed. All right, so it's important here that you think back to an earlier step. We've identified chlorine as the limiting reactant. Additionally, I already know that I'm going to make 1.29 moles of dichloromethane gas. However, that 2.58 moles of chlorine is also going to make some hydrogen chloride gas. As you look at the equation, the relationship between chlorine and hydrogen chloride is 2:2. So 2.58 times 2 divided by 2. That was a waste of time. 2.58 moles hydrogen chloride. Okay, now here's where things get tricky. We know that we've made 1.29 moles of dichloromethane. We know that we've made 2.58 moles of hydrogen chloride gas. However, as we look at the reaction, everything is in the gas phase. And although we've used up all of the chlorine and none of it remains, some of our methane is in excess. And as you read this question carefully, we're trying to determine the total number of moles of gas in the container after the limiting reactant has been totally consumed. So there's also going to be some excess reactant remaining. So again, I'm going to start with my 2.58 moles of chlorine. I'm going to think about how many moles of methane got used up. That relationship is 1:2, which means that 1.29 moles of CH4 is consumed or used up in the process of making that dichloromethane and hydrogen chloride. It's no longer there. Now let's think about how much methane we had originally. We had 25 grams of methane. So I'm going to take my 25.0 grams of CH4, convert it to moles. Oh, quick jump to the calculator. 1.56 moles of methane initially. So if I had 1.56 moles of methane initially, and 1.29 moles of it got used up, quick jump to the calculator. 1.56 minus 1.29. I'm going to have 0.27 moles of CH4 that remain. All right, so we're looking for the total number of moles of gas. We've got 1.29 moles of dichloromethane. We've got 2.58 moles of hydrogen chloride. And we've got 0.27 moles of methane that's still hanging out unreacted. So a quick jump to our calculator. Add 2.58 plus 1.29. That gives us 4.14 moles total gas. Boom. A part I. Identify the species that is being oxidized and the species being reduced in the reaction. Justify using oxidation numbers. All right, as we take a look at our equation, hydrogen here is going to have an oxidation state of +1, carbon -4. Chlorine, elemental state, oxidation number of 0. Dichloromethane, hydrogen is going to be +1, chlorine is going to be -1, carbon is going to be 0. Hydrogen chloride, hydrogen is going to be +1, chlorine is going to be -1. So as we think about what's happening here in terms of the movement of electrons, carbon goes from an oxidation state of -4 to 0, meaning it has been oxidized. And chlorine has gone from an oxidation number of 0 to an oxidation number of -1, meaning it has been reduced. So carbon has been oxidized. Oxidation number of -4 in methane and an oxidation number of 0 in dichloromethane. Chlorine has been reduced. Oxidation number of 0 in Cl2 and an oxidation number of -1 in dichloromethane and hydrogen chloride. Boom! Done.